Good morning, children. Today we are here to discuss Unit 10 Electromagnetism of a 10th class. Within this class, now we are going to discuss about a topic called as magnetic flux density, and generalization of magnetic flux for orientation of a plane. As a plane is rotated around its own axis, how that particular magnetic flux will become existing. We are going to discuss about these three topics within this particular lesson. Now first one is what? Magnetic flux. Magnetic flux is denoted with what? Pi symbol. What is called as magnetic flux? These are nothing but what? Magnetic lines of forces I have taken there, and I have taken a plane area exactly perpendicular to the magnetic lines of forces. Then what happened there? Number of magnetic lines of forces passing through this particular unit area. How many number of magnetic lines of forces are passing through this particular unit area is called as nothing but what? Magnetic flux. This magnetic flux is useful for measurement of magnetic field. This is nothing but what? Magnetic field lines which are passing through unit area. Therefore, this particular magnetic flux is useful to measure a total magnetic field which passes through this particular unit area. So this particular unit area, how many number of magnetic lines of the total magnetic lines of forces passing through that particular unit area is called as nothing but what? Magnetic flux. We can give it up. It is also useful. It is also a useful tool for everything to describe the magnetic lines of forces. Something occupying area means what? Magnetic lines of forces are occupying something, some area there itself. It is a tool helping to describe how the effects of magnetic lines of forces, the effect of magnetic lines of forces within this particular area, how it will be existing. We can easily study based upon this particular magnetic flux. This magnetic flux is also tied up with a particular chosen area. It is tied with what? Per a particular chosen area. This is nothing but what? Chosen area of any size. How much size it is there? It may be a size may be differ there itself. A small size, a large size, or medium size. Any size it will be existing. Not only that one, orientation of a plane. If it is rotating around its own axis also, no problem. Here see a plane of the paper. It is a plane and it is rotating around its own axis. In the same way, it depends upon what? It is tied with the two different things. One is what? Chosen area. Whether the area is small, whether the area is big, whether the area is moderate in size, we can understand depending upon that. Not only that one, orientation of this particular plane, in which direction the plane is existing. Exactly perpendicular, slanting, or parallel to the magnetic lines of forces. In which direction will be existing? Depending upon that, this magnetic flux will be existing. Magnetic flux it will be existing. This magnetic flux is measured by one unit, that is nothing but what? Weber in SI system. In SI system it is measured by what? Weber in SI system. Coming to next topic. What is the next topic here? Magnetic flux density is existing here. Magnetic flux density, we can give it up. What is called as magnetic flux density? It is the ratio of magnetic flux to that of unit plane area taken perpendicular. Unit plane area is nothing but what? A I have taken. Magnetic flux is nothing but what? Pi. magnetic flux is what ratio of magnetic flux to the of unit area taken perpendicular to the magnetic field. Magnetic field is what perpendicular exactly to this particular plane of the paper. They were exactly perpendicular to plane area. If magnetic flux is acting, the ratio of magnetic flux to that of unit plane area taken perpendicular to the particular field. Perpendicular to that particular field, which is denoted with capital B. Formula if I want to take it up, capital B is equal to flux is measured in what? Pi. Area is measured in what? A. Therefore, if I bring this particular A towards this direction, this is the formula for magnetic field, magnetic flux density, which also gives us nothing but what? Strength of magnetic field. Strength of magnetic field acting upon unit area, we can easily identify that one. Therefore, B is equal to pi by A gives us strength of magnetic field. From this particular strength of magnetic field, I can also calculate magnetic flux. Therefore, what? A you bring towards this side, BA is equal to pi. Product of magnetic flux density into area. Product of magnetic flux density into area will give us what? Magnetic flux. Magnetic flux, therefore BA is equal to pi when it indicates magnetic flux. If I go for units for this particular one, magnetic flux density, pi is measured in what? Weber. Area is measured in what? Meter square. Weber per meter square will be there. But we know that 1 Weber per meter square is equal to 1 Tesla. 1 Tesla is a SI unit of it, and it is CGS units is nothing but what? 10 to the power of 4. Gauss is its CGS units. It's a CGS unit. This is regarding magnetic flux density, which identifies strength of the magnetic field within that particular unit area. If you consider, next one is what? Generalization of flux for orientation of plane. Here also we have taken a plane flux there. Here also it is the same flux there itself. From strength of the magnetic field we have extracted flux. If this flux is oriented within that area, within this area, if it is orienting certain angle theta, what would be the value of that particular one? Therefore, let us take that is all nothing but what? Magnetic lines of forces. I have taken unit area. This is nothing but what? Area which is oriented certain angle theta. If I take it up, this is area. Affected area of this will be in what way? Exactly perpendicular to the plane of the magnetic field. It will be there. Plane area will be perpendicular to the magnetic field lines. The effective area will be what? A cos theta. Y means horizontally the plane we are taking there itself. Exactly perpendicular to the horizontal axis it is taking place, not on vertical axis. Therefore, A cos theta will be the value. The affected area of plane perpendicular to the field is nothing but what? Formula we had. Magnetic field density is equal to what? B is equal to pi by A. But affected area is how much? Effective area is how much? This is the area which is affected. Therefore, A cos theta will be there. B is equal to pi A cos theta. From this particular formula, I can calculate again in this particular equation in what I have calculated magnetic flux. In the same way, I am calculating magnetic flux. There is magnetic flux here of magnetic flux for orientation of certain region, the certain plane there. Pi is equal to BA cos theta if it is existing, if this particular affected area is exactly perpendicular to the magnetic field. Exactly perpendicular to the magnetic field. If I take, if it is existing in parallel way, if it is existing in parallel way means what happens there? Exactly parallel to the magnetic lines of forces. At that time what happens? Theta will be equal to 0. When both lines are parallel to each other, can the angle existing between them will be equal to certain value? No, it will be equal to 0. Therefore what? Theta is equal to 0 means what? Pi is equal to BA cos 0. Cos 0 is equal to how much? 1. Therefore BA, that implies pi is equal to BA. Pi is equal to what there? BA, same as magnetic flux, it will be equalized. This is the concept of magnetic flux, which is measured in units of Weber. Magnetic flux density, which denotes the strength of the magnetic field measured in Weber per second. Weber per meter square. Electron, which is equal to 1 Tesla, that is equal to 10 to the power of 4 cos. then afterward generalization of flux for orientation of plane, which is pi is equal to BA cos theta if it is perpendicular to the magnetic lines of forces there, which are passing through that particular unique area. If that particular area is parallel to that of magnetic flux density magnetic field, then what would be the value? It will be equal to what? Pi is equal to BA, it will be equal y cos 0 is equal to cos theta will be equal to 0. Theta means no angle will be there. Cos 0 is equal to how much value? 1. Therefore, pi is equal to BA. By this, we have completed our topic called as magnetic flux density, and generalization of flux for orientation. Try to revise this concept much more perfectly and much more clearly, just you can understand the concept. Thank you, children.